we need to first draw the diagram. A man on the boat. So let's first draw a direction diagram. This is north, this is south, this is west, this is east. So the man is here. So this is south bank. You want to come over here, north bank. So from here to here, you want to come here. There is a current in the river that flows from east to the west. Now, what should he do? Should he move? Should he move? He has three options. This way, because he knows the shortest distance between 2 points is the straight line. So should he move this way? Should he move this way? Or should he move this way? Okay. A, B, or C. The correct answer should be C. Because water, the current in the water pushing him to the left. So pushing him to the left, as it pushing his boat to the left, he will be ending up by the support of the current in the water right here. So I have a arrow over here. Let's top to tail, and I have an arrow down here. So he's supposed to find an appropriate angle, upstream angle that allows him to take the advantage of the current of the river, so it can push him, and he can arrive his destination. There are three vectors. We have this arrow, and this arrow. What are we going to call this one? Velocity of a boat with respect to the shore. Velocity of a boat with respect to the water. And let's call this one the one on the top. Velocity of water with respect to the shore. 1.85 meter per second. If this is 1.85 meter per second, this is 1.20 meter per second. Then what should be the angle? Well, it's very easy to find the angle. Sin theta is opposite. This is 1.20 by the hypotenuse 1.85. It's 0.65. So it's 0.65. So now sin theta is 0.65. So theta is inverse sine 0.65, 0.4 degree. I don't like to say fraction on the degree, so I'm going to convert it to the nearest whole number. So nearest whole number should be 40 degree. So this theta is 40 degree. So he must move upstream. His goal was very simple. His goal was velocity of a boat with respect to shore is equal to the shore. In order to accomplish the goal, boat needs to head upstream. So boat needs to head upstream to offset the current pulling it downstream. So boat needs to head upstream at 40 degrees to offset the current pulling pulling it downstream. So to offset the current, pulling it to the downstream. Okay, we're gonna now do the second part of the problem. If the person decides to use the simple definition of displacement, that is the distance between 2 points, shortest distance between 2 points is the straight line. If the person decided to go from all the way north to south directly, ignoring the current of the water, what would happen? Let's check that out. Saying this current is the velocity of the water with respect to shore is 1.20 meters per second. We want to find three things. Only three things. We want to find the velocity of the boat with respect to the shore. We want to find if the distance between if the river is 110 meter long, how long will it take for the man to cross the river? And then we want to know how far downstream the man will end up being. Okay, so number 8, we want to find the velocity of the boat with respect to the shore. Number B, if the river is 110 meter long, if will he be then? Okay, one thing at a time, let's draw the diagram again. He is south bank, he want to go to the north bank. The water is flowing from east to the west. Okay, now he decided to move across directly from south to north, ignoring the current. So let's draw the diagram. If he moves like that, the water will push him down, the current of the water will push him down. He will be ended up right here. So let's draw a vector. And now we have all the materials to draw a right triangle. Okay. We want to find out the velocity of the boat with respect to the shore. Number 1. Number 2, we want to find out, okay, that's not enough, we have to find the angle, because without angle, the velocity, we are not trying to find the speed, we are trying to find the velocity. If you don't give me the angle, then I don't know, then the information is not complete. You have to give me the angle. And then I want to know if from here to here is 110 meters, how long will it take for him to reach to the other side of the river? And then finally I want to know this distance. He will not be ended up here, he will be ended up here. So I want to know this distance. Okay, so let's do it. The first thing is very easy to find the velocity of the boat with respect to the shore, accomplished by the Pythagorean theorem. Velocity of the boat with respect to the water plus velocity of the water with respect to the shore is squared. Velocity of the boat with respect to the shore is velocity of the boat with respect to the water is given 1.85 squared, plus velocity of the water with respect to the shore is 1.20. If you do the math, if you do the first grade math, meter per second. So this is 2.2 meter per second. This is not it. I have to find the angle. I have to find the angle because the velocity is a vector quantity. I have to give the direction. How can I find the angle? It's very easy by using tangent theta. I said it many times in the class. Tangent theta is Vy over Vx. My component is the velocity of the water with respect to shore, and Vx is the velocity of the boat with respect to the water. This is opposite, this is Jason, opposite is 1.20, Jason is 1.85. As simple as that. This is 0.65. Now, if I write theta is equal to tangent inverse is 33 degrees. So the velocity of the boat with respect to the shore is 2.2 meters per second, 33 degrees. Now the second part and third part is very easy. If this is 1.10 meter long, then how long would it take for him to cross the river? From here to here, from south to north, is 110 meter long. If it is 1.10 meter long, it is very easy to find how long it will take for him to move from one side to the other side. So we just got to use the definition of velocity. Velocity is distance over time. So Vt is equal to d. Then T is equal to d over V. Now there are three components of V. Don't forget that. One is the velocity of water with respect to the boat. Velocity of the water with respect to the shore, and velocity of the boat with respect to the shore. Now we're going to use simply the same one that gives us the distance from here to here is 110. So we're going to use that component of the velocity, as simple as that. So the distance is 110 meters, and the velocity of that component is velocity of the boat with respect to the water. Velocity of the boat with respect to the water is 1.85. And if you do simple math, then that is gonna give you 60 seconds. Now the last thing we want to know is the distance. How far down the stream will he be at? How can we do that? By simple velocity. So distance is Vt. Now which component of the V now we're going to use? Very simple. We are trying to find how far downstream he will be at. How far downstream will he be at? So we're going to use this component for the velocity, this component of the velocity. And this component, we know that velocity of the water with respect to the shore. Water with respect to the shore. And time, we already found the time, 60 seconds. The distance is velocity of the water with respect to the shore is 1.20 times 60. 72 meters. So he's going to be 72 meters away, 72 meters downstream.